This is the second skill video covering Unit 1, Skill 7, and we're still focusing on compound inequalities, but now instead of looking at just some basic graphs, we're going to actually be solving a few compound inequalities. We'll look at a few examples dealing with the AND compound inequalities first, and then we'll look at one example of the OR. So let's start here with an example of a compound inequality with the AND connector. So let's do -3 is less than 2x minus 1 is less than 5. So notice we have the two inequality symbols, right here and here, and we have x kind of trapped in between those two symbols. So that's going to be typical of a compound inequality with AND. We would say this, -3 is less than 2x minus 1 and 2x minus 1 is less than 5. Okay. All right, so our goal is to get x by itself here in the middle. Okay, so let's get x by itself in the middle. So almost think of these as two kind of separators, and we need to get x by itself in this middle area. So we need to get rid of the -1 first, right? That constant needs to go. So we need to add it to get rid of it. Well, there's also these two outer sides of the problem, the far left and the far right, and we need to add 1 to both of those. Okay, we simplify in the next step. So we get a -2 on the far left. Let's bring down that less than sign. Bring down the 2x in the middle. Bring down the less than sign. And 5 plus 1 is 6. Okay, then we divide by the 2 in the middle, right, to both the far left and the far right. And then we rewrite. -2 divided by 2 is -1, less than. The 2's canceled out, so we now have x by itself in the middle. Bring down the less than, and 6 divided by 2 is 3. And this is now our answer. -1 is less than x, and x is less than 3. Then I want to represent that on a number line. We can just do simple number lines. I'm going to bring down the two boundary points, the -1 and the 3. Now this first piece, if I start reading with the x is greater than -1, right? Remember the alligator teeth, right? It's eating the bigger side, so x is greater than -1, which means an open circle at -1 and shading greater than it, or to the right. But then on the other side, x is less than 3. So we have an open circle at 3, and we're shading less than, which is to the left. Okay, now these two intervals, they overlap. Let's try this. They overlap just here in the middle, right? It's only these values in between -1 and 3 that meet both criteria, being greater than -1 and less than 3. So this becomes our final graph. Open circle at -1 and an open circle at 3 and shading in the middle. And so these two pieces go together, right? It's our final answer in inequality form and the shaded graph to go with it. Let's look at another example. I'll move this one over to the side. Example 2, this will be another AND inequality. -12 is less than or equal to -4 minus 2x is less and 6. Okay, so again, our goal is to get x by itself in this middle section here, in between these two inequality symbols. So we have to start by getting rid of the constant -4 by adding 4. And remember, we have to add that 4 to both this far left and to the far right. We simplify. -12 plus 4 is -8. Bring down the less than or equal to sign. These have canceled. There's a -2x left in the middle. Bring down the less than sign. 6 plus 4 is 10. Okay, second step. We're dividing by that -2 in the middle, so we have to do that same step to both the far left and the far right. And now we rewrite. Okay, -8 divided by -2 is 4. Now, as I'm rewriting this step, I need to be really careful. Remember, there was that rule with inequalities that when I divide each side by a negative number, do you remember what had to happen? We flip the inequality symbol, and here we have 2 of them. Both of these you're going to find flip directions. Okay, so both of those symbols are going to flip. The one on the left is a greater than or equal to, and the one on the right is just the greater than. Okay, let's rewrite the rest of this. Those -2's canceled out, so the x is left in the middle. And then on the far right, 10 divided by -2 is -5. Okay, and this becomes how we can express our final answer for x. That 4 is greater than or equal to x, and x is greater than -5. Now, notice that because we had to flip the symbols in that step, we don't have the smaller number on the left. It's now over here on the right. And typically when we give a final answer in this form, we want that switched around. So I might switch this entire thing and flip it. So it says -5 is less than x, and x is less than or equal to 4. Okay? That's also a good answer, and it keeps the smaller number on the left and the larger number on the right. And then it's pretty simple to do a number line from there. I bring down the smaller number, the -5, and the larger number, the 4. And x is like, all the x values are trapped in between that, between -5 and 4. So when I shade, okay, if x needs to be greater than -5, I have an open circle at -5, and I'm shading greater than, which is to the right, and x is less than or equal to 4, so that's a closed circle, and then shading less than, and notice we have that overlap of the intervals right in between. And so that's what our final number line graph would look like. Now let's take a look at one final example, but with an OR inequality. And typically these are a little simpler to work with. So this is an example with the OR. I'll call this example 3. So these look very separate. So like -6x plus 8 is less than 8. Or 12x minus 2 is less than or equal to -98. Now with the OR word in the middle, we don't really need to connect these two. We just keep these two inequalities separate, and you just solve them separately. Okay, so let's start over here on the left. We should be subtracting 8 from both sides. I bring down the -6x. It's less than 0. We divide by -6. And we get x. Now remember, we just divided by a negative, so this symbol needs to flip, right? and then 0 divided by negative 6 is 0. So one piece of our answer is that x is greater than 0. Now we bring down the word or. Now I want you to take a moment and solve this inequality on the right. So pause the video, and then when you're done, press play, and the answer will be up. Okay, here's the solution, our complete solution. So you should have gotten x is less than or equal to negative 8. Okay, notice we never divided by a negative. We were dividing by a positive 12 here in the last step, so we should not have flipped the symbol and kept it as x less than or equal to negative 8. Notice I brought down that connector word of or, so in our final answer it is written in there, x is greater than 0 or x is less than or equal to negative 8. Okay, so we draw a number line. Those two boundary numbers, 0 and negative 8, let's get those on there. Now remember, negative 8 is to the left, so do make sure to write that onto the left. And then we need to do some shading. So if x can be greater than 0, we need an open circle here at 0 and shade to the right for numbers greater than 0. Right, that's pointing to positive infinity. And then our second interval is that x is less than or equal to negative 8. That means we can have a closed circle here, and we shade less than to the left. Okay, they're pointing away from each other. That's very typical of an OR compound inequality graph, but that's okay. And so that's your example for an OR compound inequality. And this concludes the video for Skill 7 for solving compound inequalities.